less than 10 seconds.
Hey everyone, welcome to this week's Let's Talk Science with Morgan. How's it going, Morgan?
Good, how are you?
I'm doing great. So this week's theme, this week's activity theme, we are delving into the red planet, all in anticipation for a brand new rover that's going to be sent to Mars called Perseverance, originally called Mars 2020. And this is really exciting. It's going to be taking off anywhere between, like the end of July, beginning of August. And we're going to have a brand new rover on Mars. This is so exciting. We're going to learn so much about the red planet. We've got a fun activity for you. What do you got for us this week, Morgan?
So Mars is thought to be maybe volcanically active. It was explored several years ago for its volcanism and initially ruled out. So people really thought that there was no more volcanic activity, but now we might be second guessing that. And hopefully that's a question that our Mars rover can help us answer.
Amazing. And of course, as you were delving in, what questions did you have about Mars?
Well, a few things. So I looked into the Mars rover specifically and noticed that they've been pushing the launch date of the rover. So I'm hoping you can tell us maybe why. And also, is it really a red planet? Because some of the pictures make it look very gray.
This is true. So we'll tackle the first question. The pushing the date, that all has to do with, we mostly only have one shot. And it's a huge endeavor to send a rover like that. So all they're doing is like their checks, and I think they had something that they just wanted to like double check before they sent. So they go through so many checklists when they're getting ready for launch, and if anything is like a little bit off, they're just like, okay, hold, let's like go back over and let's check this. So they're very diligent. It's really actually like a really safe process. I wish like more systems were put in place where you just had a big long checklist, and if like any one of those things is a little bit off, you just like put it on hold and make sure, so that they're really sure that it's about to go. And NASA has like a really good track record of successful launches to Mars. So when you see some of these delays, that's usually just a good sign that they're doing their job. Now, the color of the planet, it was originally called the red planet, I think, because when you see it in our nighttime sky and you compare it to some of the other stars, it is definitely red. Like if you're looking at the colors, there's not many colors in a dark night sky. There's white, the stars, and occasionally you see some redder stars. But Mars, when you see it in the sky, definitely red. But as we've seen through telescopes and as we've gotten closer to the planet, it's more of sort of like an orange color. And that's to do because of the surface, which is made of iron. But iron isn't orange or red, but oxidized iron turns that orangey color because it's basically rusted. So that was really like the clue to tell us that there was water on Mars at some point, mostly evaporated into the atmosphere because Mars has a smaller gravity. So the solar winds just sort of came in and the water wasn't able to like hold and form like oceans. So really the debate now around water on Mars was, how long did Mars have water? Was it only for like a short period of time? Because maybe, if it was only there for like a small amount of time, maybe it wasn't long enough to really develop life. And so that's really sort of like a lot of the mysteries and the clues that we're trying to find when we go to the red planet, is that we know there was water. We know there was like a good potential for life to be there at some point, but was there? So,
interesting. So do you think NASA will be hiring an astrobiologist?
Oh, absolutely. Yeah. We're going to Mars and studying Mars. It's almost all about astrobiology now. And of course, mechanics and all the rovers and whatnot. But that's really the main mission there on Mars. And of course, when we talk about sending humans to Mars, I think of it as sending an astrobiologist maybe for like a year or so, because they would be able to do, there you go, we should send you, because you would be able to do the work of like 50 years of robots in that 1 year, because you'd be able to walk around, you'd be able to pick up a rock, and you'd be able to study it. Whereas a rover is driving around very, very slow, like just like inching along, right? And picking a few things here and there. So really that's the main advantage, I think, of sending a human to Mars, would be able to like maybe get to some of those answers a little bit more quicker and efficiently.
Would it be a sacrificial flight at this point? One-way trip?
No, I think like if the first humans to Mars, I think we should plan on bringing them back. So Morgan, let's send you there. Maybe I'll come too if they'll allow me, and then we come back and we'll figure out if there's life on Mars.
Maybe we can bring all of our viewers along with us.
Awesome. Sounds great. All right, everyone, go ahead and get into this week's Mars activity, and we'll see you next week.
Hello, everybody. So this week we are heading out to one of our nearby planets, one of the planets that is still actively being explored for its possibility to support life, and that planet is Mars. So Mars is a planet that is it's most similar to Earth as far as we know, and we have been actively exploring it for potentially sending humans to that planet, possibly to live, do other things. And so we are celebrating the launch of a new rover over to Mars, which will be used by astrobiologists to collect various sorts of samples, look again for any sort of form of water, the formation of an atmosphere through buildup of gases surrounding the planet, potentially from some sort of thermal vents or volcanic-like structures. So we do know that Mars was at one time volcanically very active, and we thought that its volcanism had halted, and that happened as Mars had cooled and magma stopped flowing freely below the Earth's surface. Below the planet's surface. But in 2019, we actually collected some data that led us to believe that perhaps it is still volcanically active and is an area of active research. Why and where do volcanoes come from? Well, volcanism is the result of a planet losing its internal heat. Volcanoes can form where rock near the surface becomes hot enough to melt. On Earth, this is often associated with plate boundaries. Where two plates move apart, such as at mid-ocean volcanic ridges, material from Earth's interior slowly rises up, melts when it reaches lower pressures, and fills in the gap. Where one plate is being subducted by another, chambers of magma may form. These magma bodies feed the volcanic islands that mark subduction zones. Although most volcanic activity takes place at plate boundaries, volcanism can also occur within the plate interiors at hotspots. Hotspots are thought to be from large plumes of extremely hot material rising from deep in Earth's interior. The hot material rises slowly, eventually melting as it reaches lower pressures near the surface, and when the material erupts, it forms massive lava flows of fine-grained dark volcanic rock, called basalt. The broad, gentle shield volcanoes of Hawaii come from a hotspot. Not only is there evidence of volcanism on Mars, but also the Moon. Mars has volcanic features that are similar in shape to those on Earth, although much larger. There are large shield volcanoes, like those in Hawaii, that contain 100 times more mass than those on Earth. A lot of the volcanoes occur in the Tharsis region around the equator of Mars. Many scientists consider Mars to still be volcanically active, even if we haven't observed an eruption in years. Basalt meteorites from Mars indicate that volcanism has occurred in the last 180 million years at the very least. Very few impact craters occur on the lava flows of Olympus Mons, a region in Mars' southern highlands, suggesting that this volcano has probably erupted in the last few million years. So the first thing we want to do today while we're building our volcano to model the volcanoes on Mars is, of course, collect all of our supplies at our workbench. So you're going to need a large piece of tin foil, a pair of scissors, a cup, a spoon, a heavy-duty plate, baking soda, white vinegar, modeling clay is optional, as well as food dye, and tape. I can't find my tape anywhere, so I'm going to proceed today by using a little bit of modeling clay to secure my cup to the plate. It'll work better with tape, of course. I can't find mine for the life of me anywhere, and again, due to the extenuating circumstances associated with COVID-19, we're encouraging people not to leave their houses for materials. So we're making do with what we have. Now, the first thing you want to do is trim your cup down if you don't have a cup that is 4 ounces in size, as indicated in the PDF instructables. So I'm going to cut this down just a little bit, just to make our volcano a little bit easier to work with. And so I'm going to cut just as such. It doesn't have to be perfect. If you're under the age of 13, make sure you've got some parental supervision, someone watching over you while you handle the sharp scissors, and don't cut yourself on the sharp edges of the cup. So once you've got it trimmed like that, you're going to secure it to the plate. I'm going to take a piece of my modeling clay. If you're using modeling clay, you want to work with it a little bit, heat it up between your fingers so it gets nice and tacky and sticky like a piece of tape would. And it really just takes a little bit. You don't need much here. If you're using modeling clay for the whole volcano, you're going to want to go ahead and build up the modeling clay around the cup to form the volcanic structure, as shown in the figures attached in the PDF instructables again. If you're using tin foil instead, it's really simple. You're just going to take a large piece of tin foil about 18 inches long if you've got a ruler. If not, it's about a ruler and a half. You can just kind of guesstimate. And you're going to take this and you're going to wrap it over top of your cup and the plate. If you've got tape, you can use the tape to secure around the sides of the plate as you go. And it doesn't have to cover the whole plate, but it will be more attractive if it does. And then what you're going to want to do is really crinkle the sides so it emulates a volcanic structure like those seen on Mars and on Earth here. If you have ever been to Hawaii, you know just what the volcanoes there look like. They're very imperfect. And if you're using modeling clay, again, just have some fun with it. Give your volcanic mountain some structure, some wrinkles. And then once you've got the foil covering the cup and the plate, you're going to want to take your scissors and pierce a small hole in the middle of the foil in the cup so that we can fold the foil down and have the crater in the center of the volcano where we are going to have an eruption. Now, similar to what we did when we were using water pressure to get liftoff with our rockets last week, we are going to combine a little bit of our baking soda and white vinegar in the cup. And if you're using food dye to color your magma, your lava, make it red and hot and flowing like it would be on Earth, you want to add the food dye first. So you'd add just a couple of drops of food dye if it's being used here. If not, you're just going to take a heaping tablespoon of your baking soda. And you're going to pour it into the center of the cup. And you're going to add about 2 tablespoons of your white vinegar. Who knew you could do so many science experiments with baking soda and vinegar? Again, if you didn't tune in with us during the rockets video last week, the chemical reaction that happens is an acid-base reaction where the acid is in the vinegar and the base is the sodium bicarbonate, which is the baking soda. It undergoes a fast chemical reaction where a lot of bubbles are formed because there's a very rapid breakdown to carbon dioxide, which of course is a gaseous species at room temperature and bubbles and evaporates very quickly. So, spoiler alert, we're about to get a lot of bubbles. There we go. Voila! So there you have another very simple and relatively straightforward science experiment you can do at home in order to explore Mars. Tune in for the launch of the Mars rover and stick along with us as we collect data from that rover and we learn more about the possibility of life on Mars. Until next week!